here's a problem that we are facing with all of these biometric measures. The problem is that there is some uncertainty in the recognition. So ideally you would like the system to say yes or no, which, like in this picture, you would like to get a 0 or you would like to get a 1. It's a valid or invalid. Just like a password, it either matches or it doesn't match. Unfortunately, with the biometrics, it's never black and white. There is always some uncertainty. So the system is going to generate a number between 0 and 1. 0 is definitely an imposter, 1 is definitely a correct, valid user, but anything in between is subject to interpretation. And so you end up with a bimodal distribution, like in this picture. Most of the faked attempts will be clustered around 0. Most of the genuine attempts will be clustered around 1. And so you put the boundary between those two. So anything to the left is no, anything to the right is yes. But unfortunately, sometimes these areas overlap. If the method is very flaky and it's not very reliable, it will give you some numbers or some imposters that actually overlap the genuine attempts. And so you have to decide where you cut it off. So if you cut it off, let's say here at this point, very high, no fake imposters will be able to get through the system, but you will annoy a whole bunch of people who are legitimate users who will be rejected, and those are false alarms. Now, on the other hand, if you put the boundary here to the left, well, then all the genuine attempts will get through and everybody will be happy, but there will be some number of fake that actually slip through. So it's a policy issue to decide where you want to cut or how many false alarms versus how many imposter acceptances you want to accept in the system, and it depends on the application.